warm my heart to Brigadier Bipin Trivedi, moderator, Engineer Ashish Kumar Chakravarti, convener, Engineer Nachiket Nagre, organizing secretary, for organizing such a wonderful webinar with the brilliant panelists. Thank you, sir.
Thank you, Engineer Prakash Chandra Dubey, Chairman JLC. May I now request Dr. N.T. Ranga Reddy to briefly talk about the theme of this morning webinar. Dr. N.T. Ranga Reddy, Chairman, Legend Technologies.
Thank you. Respected Mr. Prakash Chandra Dubey, Chairman of Jabalpur Local Center, and our most respected panelist and the Director of Naval Science and Technology Laboratory, Dr. Y. Srinivas Rao, and our Vice Chancellor, Dr. Viplav Paul, and moderator of the program, Brigadier Vipin Kumar Trivedi, and our Honorary Secretary of Jabalpur Local Center, Sanjay Kumar Mehtaji. And very good morning to all of you. Since inception in 1920, the Institution of Engineers India has upheld the mandate of promoting and augmenting the science, practice and business of engineering through different technical activities and providing insight to the policymakers regarding matters related to engineering profession. Imparting engineering education for working community in non-formal mode, cooperation in engineering and technology, dissemination and sharing of engineering and technical knowledge through activities, contemporary topics, and encouraging, elevating, and recognizing the technical knowledge and practice of individuals and organizations through scholarship and awards. Standing at the crossroads of a century of a glorious existence, a little marred by the global pandemic, it was felt appropriate to rethink, introspect, and disseminate ideas, concepts, and best practices in the engineering areas of technology and engineering through virtual platforms, which finally have evolved into IEI Technical Webinar Series. Today, we shall deliberate on the topic of role of mechanical engineers in missile systems, with the objective to focus the insight and prospect the scope and expertise of mechanical engineering in aerospace industry in general and missile systems in particular. The defense sector of India has gained considerable expertise in developing in air defense, ballistic missiles, defense systems, with the significant contribution from the most competent aerospace and mechanical engineering domain. For many years, this competent work group has played an influential role in the development of air-to-air and ground-to-air missiles for air defense. The mechanical and aeronautical engineers, with their joint effort, developed a unique resource of personal and specialized computer hardware and software to effectively practice the discipline of computational fluid dynamics throughout the missile development process. A suite of CFD codes is regularly used to predict the performance of conceptual missiles, support and supplement wind tunnel tests, aid in the development of flight critical hardware, and support forensic analysis of flight anomalies. Further research in aerospace and mechanical engineering is continuing to explore the investigate new avenues of thermodynamics and structural mechanics. New research is in full swing in climate modeling, experimental fluid mechanics, fixed wing aircraft design, laser-based advanced manufacturing, human-robot interaction, remote sensing of environmental flow, and more. Hopefully, this technical webinar on the role of mechanical engineering in missile systems, being organized by Jabalpur Local Center of the institution under the aegis of Mechanical Engineering Division Board of the institution today, will be relevant for the professionals, practitioners, and researchers, and will be successful in portraying the opportunities and challenges in application of mechanical engineering principles and practices in missile systems. Today, I would like to thank Jabalpur Local Center, especially the Brigadier Vipin Kumar Trivedi sir, for bringing a wonderful panelist, especially a great outstanding scientist, and also an academician, a vice chancellor, and also a person from a manufacturing. It really makes the end user, the three different groups came together, and I would like to congratulate and compliment Jabalpur Local Center Chairman and the team for organizing this webinar on Sunday. Thank you very much.
Thank you, Dr. N.T. Ranga Reddy. Now I'll proceed with the address by the panelists. The first panelist, of course, I invite is Dr. Y. Srinivas Rao from NSTL, who is director at NSTL, and he's joining us from Visakhapatnam. Dr. Y. Srinivas Rao is an outstanding scientist, took over as director NSTL, that is Naval Science and Technological Laboratory, on 31st of May 2021. He's a graduate with distinction in mechanical engineering from JNTU Hyderabad and has obtained his PhD in mechanical engineering from Osmania University. He started his professional career at BHEL Hyderabad as an expert in the areas of manufacturing of steam and gas turbines and centrifugal compressors. Later, he joined DRDO Hyderabad in the year 2000 and worked in various capacities in the missile defense program. As project director of EXO Interceptor missile system, he led a team in configuration, development, and realization of the state-of-art hit-to-kill interceptor missile system capable of intercepting incoming missiles in EXO region. Dr. Y. Srinivas Rao is a recipient of Sir Mokshagundam Visvesvaraya Award as Eminent Engineer from Institution of Engineers India, Telangana State Center. He is also the recipient of a number of DRDO awards, to include Agni Award of Excellence in Self-Reliance in 2005 and 2009. He is the first scientist to lead the contingent command for ASAT Shakti mission at the Republic Day Parade on 26th January of 2020. Request Dr. Y. Srinivas Rao to give his presentation, please. Dr. Srinivas Rao.
One second, I'm just loading the presentation. So, meanwhile, let me thank you for giving me this opportunity. I received a call about 1.5 months back from one of our local centers, Sachana and Dr. Sachana, who was the ex-CITD, and he was also chairman for Institute of Engineers Hyderabad for a long time. And he called me and asked me, can you give a presentation? Then I said, I moved out to Naval. Hello? Hello? You're able to get me?
Yes, sir. Yes, sir. Please go ahead, sir.
So I moved out to naval systems. I'm no longer in the missile. Then I said, having worked in 20 years for the missile, you are the apt guy. That's what he told me. Hope I'll do my justice today. But for all the youngsters, if there are there who are participating, today engineering is changing dimensions very, very fast. You all know that the number of intakes for mechanical engineering is coming down, but then the overall engineering as a basics, I feel mechanical engineering as the ground basics that has to be done. Even today, when we are working for even in completely automated control systems, I see a lot of requirements where mechanical engineer role is there. At the same time, we are also looking at that the role of mechanical engineer to the tradition of having only to look at the mechanics or the guide or the harmonics or the gears or the automobile. It's not there anymore. We have to graduate to intelligent systems. So the bridging has to happen quickly and very fast. Otherwise, the relevance will be lost very soon. So this is what I felt, having been there in many college boards and advocating. We are talking about more and more bridge courses where a mechanical engineer will now emerge as a total engineer who can do an intelligent systems. And missile system is one of those app systems where it is completely intelligent system. Missile system, you cannot put a human in place, and it's a interlinking of so many systems of systems that as I go through, I'll explain then how we come into various systems of systems in the mechanical engineering. I think my slide has shared now. It has come up.
Yeah.
So this is what I wanted to say. So before that, engineering is a great profession. This is the quote which I took from Herbert Homan, US mining engineer and the 31st president of the US. He has given a very good quote on the engineering and society. Engineering is a great profession. There is a fascination. I'm just having a little bit of my slides. Is it some problem? Okay. You hope it is visible now.
Yes, visible.
Okay. So engineering is a profession where there is a fascination watching a figment of the imagination emerge through the aid of science to a plan or paper. Then it moves to realization in stone or metal or energy. Then it brings job home to men, rather women also. Then it elevates the standards of living and adds to the comfort of life. That is the engineer's high privilege. To the engineer falls the job of clothing the bare bones of science's life, comfort, and hope. And what he has told in the early 1950s or 40s is relevant even today. Now, the Babu is slide को picture है वो.
अच्छे से खाओ बेटा, छोड़ो नहीं, साइड का भी काट के खाओ ना.
Full screen लगो ना.
सेम की बनाए दूसरे वाले की.
Full screen करो ना.
ठीक है ना. So, what do we look at it? We look at it that he should have a good understanding of design and manufacturing process. It's a multidisciplinary. I'm just covering these elements where an engineer, as a totality, if you have to work as realizing a full system from the ground scratch, what he has to be. He should know finally whether it's economically it can be produced and environmentally, and today we are talking about ergonomically. And it finally meet the service or the customer needs. The engineer should also have both the communication skills, both written, oral, and graphic and listening, highly ethical standards, and ability to take the feedback and flexibility to adapt as per the situation, and also aware of what is happening around the world. And these are the forums today which we are meeting. Gives me an immense opportunity to have those sharing about what's happening around us. Any engineer cannot happen without having the basics of the science. Even today, when we discuss, when we decide, when we think of a concept, we come back to the core science. That is where we stand, whether it's a mathematics, how we compute it, how we convert it into or as physics or chemistry, with which we together we bring it out to basics of what we are going to have as a thorough engineer. Now coming to the rockets and missiles, where I'm going to use this. I'll skip some of these slides. These are not relevant for this August gathering because it's for the too general gathering. I'll come back straight to the where from Dr. Kalam's quote is when we started our missile, and especially when I started missile defense, because I started it with Dr. Saraswat when we were in the inception. That is on paper, when many people said hitting a bullet to bullet is an impossible thing. That's where we started our thing, and you all know we have ended up hitting a satellite. It took us 20 years, but then we went through the challenges. And this is where we always remember from our guru, our mentor, who guided us throughout as we were building up generally, Dr. APJ Abdul Kalam. Anyone who converts a challenge into an opportunity to innovation creates history. He or she is leader. Are you? This is a question he keeps asking. And this is a question which we keep asking. This is a question we tell all our scientists and engineers to keep asking among themselves. The advancements are always there. And through a direct approach, we go through the targeted goal. And aerospace technologies has been the technology drivers during the past century with unprecedented growth and would remain so in the foreseeable future. Let the institutions and universities be incubators for this technology, and you will be the future technocrats for these areas. Let the industry be the partners in development and take lead in establishing the latest manufacturing facilities for high quality standard products. And as a DRDO, we continue to work with the industries. We continue to work with academic institutions to achieve
ever challenging goals was the request, and with the Atmanirbhar Bharat. And today, we are proud that in the missile technology, we are truly Atmanirbhar Bharat. So take me to the innovations in missile technology. Now, what we had, let me start with the 1980s when we started this missile technology, and a little bit of rocketry which we did at that time from the form of PSLV. We did not have a good knowledge. Our thinking were low, and we had to come out with an opportunity. And what the IGMD program did was to create these reduced restaurants, give us self-billing among us, and convert the opportunity into a reality. And we have seen the problem of design of a missile system from a point to point like a Prithvi or Agni for higher ranges, or an Akash, which is an intercepting an aircraft, or a Nag, which hits a tank, which we have come out with a very, very complex guidance laws. And today we graduated to some of the most advanced missile systems. So also, if you have to look at, there was the around us, the world around us, the neighborhood around us, has made us also to shift the priorities very constantly. There was a continuous technology dominances that are happening, and we have to think in a short-term manner, in a long-term manner, both, and focus on a real challenge where we had to convert our opportunity to goals and keep our nation always strong. So this is where we changed ourselves. And from the days, if you have seen in the 1954, this famous where on the cycle the rocket has been carried to an ICBM launched in 5,000 kilometers in 2016, India has grown a long way. And where we come as an engineer, I hope people, if you look at it as a missile, as a system, if you look at, we have the propulsion system, which gives the thrust. We have the control system, which constantly corrects its position and leads it to the region at which it has to reach. The navigation system, which is coupled with the GPS now, and with our own Indian system, IRNSS, which today we are having. And then in the front, we have the onboard seeker systems for the anti-aircraft or anti-missile, or a altimeters, or a homing system as required for the end game applications. And then overall the airframe itself, based on whether it's a hypersonic, whether it's a low subsonic missiles, the airframe itself has been designed from aluminium to the titanium and to the most composite systems that we are having. Hope I'm comfortable. My voice is comfortable. I'm not going fast. Is it okay?
This is perfectly fine, Dr. Srivastava.
Yeah.
I believe somebody's audio is on. Will you please switch it off?
Yeah, somebody's audio is on. That's why I'm asking.
Dr.
Kindly mute yourself, sir. Speaker is
Kindly mute
delivered
Dr.
his
Sanjay Kumar
lecture.
Mehta ji. Sanjay Kumar Mehta ji, please mute.
Prakash Chandra
Honorary
Dubey.
Secretary, sir, kindly unmute yourself. Mr. Sanjay Kumar Mehta, kindly unmute. Kindly mute yourself, sir. Kindly mute.
Yeah. So now, is it
Mr.
okay?
Sanjay Kumar Mehta, kindly mute yourself, sir.
यार रखो घर में खर्च कर दे सही निकाल देते हैं.
Okay. Now, if you look at these missiles today are also linked with a data link, which we are on the real-time mode. We are also giving the target's position to the system. That's where the network-centric warfare has come into place, which I'll be covering in brief. Regarding the missiles, we have the intercontinental missiles, short-range missiles, medium-range missiles, depending on the range, and they're available. They are available as on the screen. Okay.
देखो कितना अच्छा कर दिया, देखो तो अच्छा बड़ा बड़ा दिख रहा है, तो अच्छा बड़ा बड़ा दिख रहा है, हो जाता है स्लाइड।
Okay.
जो भी बोल रहा है कि अच्छा दिख रहा है, बड़ा बड़ा दिख रहा है, उसका माइक ऑन है, प्लीज उसको पर्टिकुलर माइक को बंद करें, म्यूट करें, स्पीकर को बोलने दें प्लीज।
Can I continue now?
Yes sir.
So now look at the area in which mechanical engineers how to work, and it giving me that point of mechanical engineer. Then there are other areas they have to work in together. So for example, a guidance missile, aerodynamics, control and guidance, structure, propulsion. Now instrumentation, I put it why mechanical engineers to learn, because the structure and control, the structural noise directly implants to the control, and the structural failure and the control are interlinked. So instrumentation is the one which gives him the position. So it's important for him to know in each of those subjects in addition to the basics of mechanical engineering where he had to work. That's where the missile system has got a huge role of interlinking of the subjects. Ooh. My screen is not going to the next slide. There is screen selected. Just hold, my screen is not going to the next slide. Now it has come.
Yes sir, it's come.
So I'll just touch upon each one where the role of engineer happens. Now if you look at basic aerodynamics, this is a fundamental basic diagram which any aircraft or a missile system takes thought in, at the intermediate level. The thrust and drag, lift and weight. This is the four coefficients which we work on for any system design. So we work on these aero parameters, and from there, from a point mass, we build the complete trajectory simulation of the system. Then here, basing on the Reynolds numbers, we come out with a subsonic flow, transonic flow, or a supersonic flow, and eventually the profile gets designed. Whether it should be a wing surface or a front canards or a control system, here control systems are required. And what are the moments, moment angles required, moment rates have to work, comes the detailed physics that we have to work out. This is where we develop a series of equations, and that's where the role starts from the design point of view when I design a system, a missile system. The next comes the propulsion. Now, if all the missile has to reach to a particular region, what is the thrust required? The thrust again goes back from the what is the drag component for it, and what is the mass component for it, and overall thrust, and the time in which it has to reach dictates me what type of thrust I have to give. And this all of us know that it is from the basic Newton's laws of equation. And where are the if I classify these propulsion systems, we have chemical energy, nuclear energy, today solar energy, electrical energy, ion, magnetic plasma. But in all of missile systems, we are now using basically the chemical energy. Regarding the types of vehicles, today we have aircrafts, missiles, space vehicles, even a rocket projectile. And the type of propellant, I have solid propellant, liquid propellant, hybrid propellant, and gel-based propellants which we are working on. But the major portion now has been taken out by the solid propellants because of the ease of operation, and especially when we are doing underwater or from the ship launches, we are working more on a solid propellant. And the size also depending upon the number of stages, number of propulsions, and the type of feeding systems it works. We have in a missile system, we initially have if it's a single stage, there will be only one propulsion. If you have a multiple stages, then we have a booster stage, a sustainer, and then the final endgame stages we have. Then any missile system is an autonomous device. It goes on its own to the position. So it is either command guidance or through an active guide homing system, where the initial handing over error is given by the command from a wired or unwired. Nowadays, it's totally unwired through a data link, and then with the handing over error, the radar, or what we call it a seeker on the system, which we have today, phased array seekers in a different bands, KU band seekers, KA band seekers, based on the range, accuracies, and speeds, which home on to the target and gives the position in which the angular information that is given to the missile system, and then the missile control system takes it over towards it. So the missile has got a guidance system which actually measures its current position vis-a-vis the target position, and then steers it towards it and corrects the errors. And how do we know this position? This is by the typical sensors. These sensors are inertial sensors. Now major portion are used by the inertial spaces, and especially the major applications today that has been used are ring laser gyros. All of you know from the old traditional gyros compasses. We also use celestial sensors depending upon the application requirements. And as the guidance takes it, it navigates. And how do we navigate? We do a hybrid navigation where we have the sensor picking up the data, and we hybrids it with the GPS position, and together here is the hybrid navigation, if you see that, and this portion of the INS and the GPS is fed to the onboard computer. The onboard calculator then calculates the position accurately and navigates the system to the required position. Now we have missiles in a different modes. We have a silo launch, which launched from the underwater. We have ship launched, where Dhanush is one example, but we have got many other. BrahMos is also another example where we do a ship launch. Then submarine launched. We have rail mobile systems. We have a road mobile systems. We have got a air launch systems. So all launch programs have been proven today. Now coming to the next system, we have a missile systems which are forming a threat, and you know the entire neighborhood is also having the missile systems. Now how do I counter this? Because a missile system can be lethal and it can carry, all of you know, a strategic payload also, and it can be devastating if it hits. And it comes with a very high speeds of Mach 5 to Mach 22. And now we need to look at, because if this is the lethality zone at which the missile intercepts and hits it, we need to intercept it somewhere here. And how do I do it? That's where the technology comes in place. If you look at the trajectories, people can launch from as far as the other part of the earth onto our territory. And how do we pick it up? And how we handle this is, we have a combination of network-centric engagement, we call it. We have a ground radar, which first picks up the missile after it takes off, and the ground radar has to classify it. So there is a classification. So, and most of these things are done by the phased array radars. I'm not getting into deep of how the phased array radars are functioning, but what we get is through a Doppler shifts, we know the velocity and the kinematics of the missile that is coming up. Then we can identify whether it's a missile, whether it's an aircraft, or any other object that is coming towards us. And we can, with those kinematics, we can actually predict where this missile comes onto the ground and where it reaches the area which can cause destruction. We can predict the velocity and range of that missile. We can predict the altitude and trajectory path of it. All these things are done automatically online. An online algorithm classifies it, calculates it, and then it is sent to a command network where launchers are kept with the ready missiles in the ready condition. The missile at that stage is in a cold state, that is, missile is not powered on. The moment the missile is given, the position is of that there is an incoming target coming in. The kinematics of this missile target is now fed out of the missile that is at the ground station, which is likely to intercept it. And this missile has to be switched on. It has to be stabilized. Its INS navigation system has to be stabilized, and then the compassing has to be done. It has to be given its own position coordinates, and And then once these position coordinates are done, then the ground information, guidance information has to be fed it, and then the launch command is taken after calculating precisely at what time it can intercept based on the thrust calculations of this missile. So this is the enormous amount of background exercise that happens before an interceptor missile gets launched, and all, mind you, will happen within less than a minute or 1.5 minutes, depending upon the type of engagement and the altitudes at which it has to engage. And this is what a technology has changed today, with a wide-centered network warfare coming into place, and with the ground radars available across this belt, and trying to interface all of them is what the challenge is all about. And that's where the engineering role comes, and in every stage of it, mechanical engineer role comes in. Say, doing a network cable architecture, or cooling systems for the radar, or the radar motion of the radar, or stabilizing the radar, or launchers, design of the launchers, or position of the launchers, or the missile systems. But then everywhere the role of mechanical engineer is there. But then on the mechanical engineer, there's one more layer of intelligence that comes in, which is part of the system. This is where I was explaining you all how in the different segments. Different segments we can see how the tracking can be done at different locations, how a missile system can be intercepted. Also, if there are multiple kill vehicles can be created, generated. Also, a decoys and they can be discriminated and intercepted. These are the various systems that have been developed across the world. And just what I have explained is now in the further slides. So if there's an end game, I need to do the aim point selection. Aim point is the precise point. If you are looked at how we have intercepted the satellite, within a 1 centimeter accuracy we intercepted for a satellite which was moving at 7,500 kilometers per second. Correct me, I think some number is wrong, around that speed. And then the terminal guidance is where the seeker acquires with the handing over error from the ground radars. And then the mid-course, I'm just going behind the ground sensors, which gives the position of the target and gives it to the interceptor. And then the vehicle control at the initial launch. This is how the handing over takes place. You are seeing from the target, the handing over takes place. Initially, it comes with a huge error. The seeker ensures that the error is mitigated and homes on to the target. These are the various angles in which how the lethality of it. If I am intercepting with a warhead or I am intercepting with the direct hits, the lethality calculations have to be done on the back end of the system. And all these things are years of exercise which we have built in-house, the complete softwares within our system. So if we have to do, we today do it in defense in the exo-atmospheric, we do defense in the endo-atmospheric. Exo-atmospheric is a layer in which we intercept it above the atmospheric level, where the discriminations or the decoys are very low and interception is easier. But then if there is a leakage, then the zone in between 18 to 20 kilometers, generally exo is above 80 kilometers, and between 18 to 20 kilometers or 40 kilometers we do an endo-atmospheric. Here we can directly intercept the one which is actually having the warhead is easily intercepted here. But this we do after if there is a leakage from the external source. But we adopt a shoot philosophy, not a wait for the philosophy. That's what the world adopts today. And this can intercept many kinds of. We do not know what warhead payload the other person has, so it has to take care of those issues. So these are the various payloads that can come, and our issue is to intercept them. So what are the features? We need to have an optimal trajectory. We need to have a high velocity to intercept an incoming missile. We need to have a deceleration in the drag portion. Warheads can be monolithic, submunition, or a direct hit. There will not be any warhead also. Very small radar cross sections, very accurate systems, and some places we use the infrastructure signature also using the IIR systems. So this is how the 21st century network operations warfare has changed, and database and data mining has come into a big, large, and now the system has emerged into a family of systems where an integrated approach from the air and surface defense takes place. That is, you have a satellite, you have got aircrafts, you got a missile systems, and all are coupled with a networked data on a high-speed network, which we have seen, including the calculations and the switching on and launching of systems in less than 60 seconds with no human in loop. See that what the technology is making it happen. The geographical boundaries are changing. With cyber security is coming in place, the entire war scenario is changing. The target it's no longer the one area or one battle space. The entire world is changing, and according also the technology, every 3 years there's a abnormally high jump in the technology sectors in every area of the system. So this is where we have to adoption for change is absolutely essential. Military is changing. The rules of engagement are changing. I'm not harping much on these factors. This is for the political. I'm not going to harp much on it. But then we have to be ready for such kind of scenarios. And at a very, very short notices, we might have to be ready with some of the high precision, high accurate systems on ground. This I skipped. This is what the robust network architecture which we are talking about with complete protocols in place. The command and control is now decentralized command and control. Command and control is also being shifted to one to shift. There's the shadow commands and shadow controls also coming, and optimization making is happening, which will giving a leverage that from any place in India we can have a command and control for any other place or for operation. So this is how the C4I, the intelligence system, surveillance system, reconnaissance system, communication systems, computers, command and control systems, all put together. Today, the network-centric warfare is what is making us a defense mechanism stronger. And as a country, as a nation, it's important for us to grow in this direction continuously and with the required security measures in place. Now, just to touch upon a few points in manufacturing, why I saw that there is going to be a presentation on manufacturing. I am not going to go my slides on manufacturing because there is a presentation manufacturing. But I just wanted to mention that the dynamics and the missile systems and even in for torpedo has changed rapidly with the 3D printing and the adaptive manufacturing are coming into place. No longer we are going with the conventional routes of a regular ships. Now we are shape optimization, we are able to do it. We are able to create a complete, for example, if I have to create a structure with internal grids and also the junction boxes, all my wiring, electrical wiring system, it's all changed with the 3D printing that has come in, and metal 3D printing in the last 3-4 years is changing very rapidly. With this, many of the systems which were initially we used to make it circular or spherical have now become toroidal, and the space and mass has gained. Also, the grain configurations for our solid propulsion, the grain sizing also has changed because of these advancements in manufacturing. And this has actually changed the way, the philosophy we operate. That is the speeds, the thrust that we can give for a very lesser weight and mass. The mass has come down, the thrust has increased, and overall controllability, precision has increased. I'm able to make a nano control systems of this. And this is how we could convert our systems. And operations wise, it has become a global manufacturing operations. Today, the design can come from one place and the product is coming from another place, completely not linked to each other from the remote locations and no longer it was that a city or a small aerospace regions that is giving us today. The entire country or entire world is open for us for manufacturing. This is how the operations are completely changed today for us. So I will not touch upon the other factors of this the systems because these are all now for the expert to take care. But I only wanted to mention here that our aerospace industry is doing a extremely fast changing because of this adaptive manufacturing that has come into place, especially when we are talking about the metal depositions.
I'm not talking about just the 3D printing, but we were able to make metal depositions very, very successfully and create a composite mode of structures which are lighter and can take about hyper velocities, that is with the high temperatures, as high as 1500 degrees centigrade temperatures. We are able to take, in fact, jet vanes we are able to make with 3000 degrees centigrade with silicon carbon and other elements which we are able to process today with these advancements in technologies. And this has changed the game changers in what the missile technology is all about. And there's a huge responsibility, we as engineers, to come and go ahead. So just to conclude, our country, we've got a vast natural resources. We have got this may be the older figure because I downloaded it from the net. So this is, we have got a huge human resource, young resource, enterprising resource. Today I see many startup companies coming up from the youngsters and they come up with the brilliant ideas. If you had look at our technology development fund schemes, which we are offering today, many youngsters are coming up with wonderful new ideas in the TDFs. At TDF, you know that we have increased up to 50 crores we are funding, and we are coming up. They are coming up with the beautiful research activities. They are coming up. We are coming up more and more mission projects, and thanks to this government, where it's completely Atmanirbhar Bharat, we have to do it in India. We have to do all the future weapon systems. We have to build in India, and I'm sure with what is happening today in this country, with the economic prosperity which we have, the thrust which this government is giving, and the thrust which we have made it to defense and aerospace sector, the India is going to be a world leader and export house. From the importer of weapon systems is going to be an export house. This we are seeing it very shortly because the rapid changes that is happening, and we are seeing it directly on ground when we are able to build technologies with the industry participations, and that is what is changing. Thanks to the Indian industry that has come up a long way. Thanks to the academic institutions who are now concentrating more on the fundamental research and working it with us very closely. Many universities are coming to us with open-ended thinking and with taking up the responsibility to come to the end solutions. So with this, I'd like to end up my presentation. Thank you very much for giving me this opportunity. Over to the moderator.
Yeah, thank you. Thank you so much, Dr. Srinivas Rao. It was an excellent presentation made by you, which I'll sum up at the end of all the three presentations by the panelists. Now, the second panelist I would request to come and deliver his presentation is Dr. N.T. Ranga Reddy, who's a technocrat and industrialist with more than 30 years of experience in the field of aerospace design, manufacturing, assembly, tool manufacturing. He completed his MTech in tool design in 1986 from CITD Hyderabad. He began his career with Hindustan Aeronautics Limited, Bangalore in 1986. He then went on to begin his own venture, Legion Designers, in 1992, which is now Legion Technologies Private Limited at Bangalore. As chairman and MD of the Legion Technologies, he has been involved in several domestic projects such as light combat aircraft, advanced light helicopter, light combat helicopter, light utility helicopter, and Jaguar, and also export projects like Boeing and Airbus. He has participated in manufacturing, assembly, and testing of ISRO projects like PSLV, GSLV, and RLVTD and Gyanyan projects. Tooling and assemble manufacturing of DRDO projects like Lakshya UAV, Prithvi missiles and UAV, CSIR lab projects like Saras and Hansa. His greatest achievement is signing of an MOU with Government of Karnataka to design and develop two-seater India's first ultra-light helicopter in the presence of Defence Minister Shri Rajnath Singh on 5th of February 2021 at Aero India, Bangalore. He has been awarded Young Entrepreneurs Award by IIE in 1994, Udyog Bharati Award, New Delhi in 2011, Best Alumni Award of IIE India, Bangalore in 2011, IIFS Award in 2012. Now I request Dr. Ranga Reddy to give his presentation, a person who has traveled a lot in many countries like USA, Russia, Israel, Kuwait, Italy, Singapore, Germany, Spain, Portugal, Sri Lanka, and Nepal. We are honored to have you, sir. Please go ahead.
Thank you, Brigadier sir, for a wonderful introduction. We don't maybe doesn't need of so much, but anyway, thank you very much. And being a host of from Institution of Engineers India, I think I would like to take very little time and give much my time to our upcoming speaker, Dr. Biplab Paul. And first, I would like to thank Dr. Brigadier Trivedi sir for wonderful introduction, and also especially Dr. Y. Srinivas Rao, Director, Naval Science and Technology Laboratories. Sir, normally our aircrafts where we are in the business will fly only Mach 2 to maximum 3, but our missiles fire, as sir was telling, Mach 5 to Mach 25 speed. And his presentation was wonderful, and his presentation was so speed and so fast that I think we would have given some more time to the sir, and we would have taken less time in the manufacturing sector is concerned. And before we, as I said, I was just reading the NSTL motto. They say strength origin is in science. So the manufacturer's work only starts when the great scientists, like outstanding scientists, investors, are the whole design parameters of what they have done and what is the requirement as per the utilities, then the manufacturing engineering come into picture. So I would like to just show some of the slides. In the content will not take much time. I will be just concluding and giving a time for others. What are the missile systems in India? The content goes, then type of missile systems and the role of mechanical engineering, and is a conclusion part. And as sir was explaining the missile system, I just would like to define maybe the types of missile systems available, where we are a part of most of the manufacturing parts for different missiles and launch vehicles in India for last 3 decades. The missile system is a military terminology. A missile is a guided airborne ranged weapon capable of self-propelled flight, usually a jet engine or a rocket motor. Missiles are thus also called guided missiles or guided rockets. When in rocket form, missiles have 5 system components: targeting, guidance system, flight system, engine, and warhead. These all the 5 system components were very well explained by Dr. Srinivas Rao. And I just would like to say the type of missiles which were there in the part of missile systems in India and abroad. One is the surface to surface missile, we call SSM, or a ground to ground missile, GGM. Air to surface missiles or air to ground missiles, surface to air missiles or ground to air missiles, and air to air missiles and anti-satellite weapon, AS it called. Surface to air missiles or ground to air missile is a missile designed to be launched from ground or the sea and strike targets on land or at sea. They may be fired from handheld or vehicle-mounted devices, from fixed installations, or from a ship. They are often powered by a rocket engine or sometimes fired by an explosive charge, since the launching platform is typically stationary or moving slowly. They usually have fins or wings for lift and stability, although hypervelocity or short-range missiles may use body lift or fly a ballistic trajectory. The photo which we have just shown, which was taken in the world, the flying bomb was the first operational surface to surface missile. And we go to the air to surface missile, we call ASM, or air to ground missiles. It is a missile designed to be launched from land or sea. There are also missiles. The 2 most common propulsion systems are air to surface missile or rocket motors, usually with a shorter range, or slower long-range jet engine. Some Soviet-designed air-to-surface missiles are powered by ramjets, giving them both long range and high speed. My slides are struck. You're able to slide screening is happening.
Yes, we have now the second. Now we are at the SSM GGM.
Yeah.
Yeah. Next, please.
I think we
Yeah.
just surface
Now
air.
we got that air to surface missile. Yeah.
Yeah. Sorry, I think there is some challenge. Surface air missile and ground air missiles, also known as the surface air guided weapons, is a missile designed, launched from a ground to destroy aircraft or other missiles. It is one type of aircraft.
Sir, your slides are not visible, sir. Kindly. Yes, sir. Yes, sir. Yes. Okay, sir. Okay. Okay. Thank you, sir.
Visible?
Yes, it is available. Yes, sir. It is visible.
Yeah. I have replaced most of the forms of dedicated anti-aircraft weapons with anti-aircraft guns pushed into specialized zones. And air-to-air missiles, it is a missile fired from an aircraft for the purpose of destroying another aircraft. AIMs are typically powered by one or more rocket motors, usually solid fueled but sometimes liquid fueled. Ramjet engines, as used on the Meteor, are emerging as a propulsion that will enable future medium-range missiles to maintain higher average speed across their engagements. And anti-satellite weapons, there are space weapons designed to incapacitate or destroy satellites for strategic or tactical purposes. Several nations possesses operational anti-satellite weapons systems. Although no anti-satellite weapon systems has yet been fully utilized in warfare, a few countries like China, India, Russia, and United States have successfully shot down their own satellites to demonstrate their anti-satellite weapon capabilities in a show of force. ASATs have also been used to remove decommissioned satellites. And as I said, is the role of mechanical engineers in a missile system. And already our earlier scientist has spoken about 3D printing in a mechanical 3D printing is going on there in the latest manufacturing process. But I would like to say that basically the mechanical engineer work starts once a scientist give a design for any of the systems or missiles or rockets they are going to use. And planning and executing of mechanical designs, I think now most of the mechanical engineers are aware that we use the CAD and we use the CAM and the 3D CAD programs, and that is where the first starting work goes. Once you design of the systems done by a mechanical engineer as per the requirements of the forces which they are looking for, what is an object required, what is the product they are looking for. Then we go for a performing of analysis and computer simulations and experiments to virtual test and refine the designs. Once the first basic design, and after analysis, feedbacks, and computer simulations, the whole product will be given for the testing and redefine the designs. Then you start the first proto and involving the machining, fabrication of the systems and subsystems till the assembly of the final program, it will be done. And this the machining, as we are talking, that is the tooling is the first of the part of in the manufacturing engineer goes. And maybe as we say, I would not like to go through the total manufacturing system of a missiles, what we do, but the systems, whether it's a mechanical systems, then you do a divided into number of fuselages, first stage, second stage, third stage. Then you manufacture all the stages there. We'll have a lot of, whether it is a sheet metal or a machined components, either extrusions, or as I said, a 3D printing components. And we also do all the parts with all the manufacturing process we do the requirement of heat treatments, and there's a final detail parts are manufactured. Then the tool or sub-assembly jigs are manufactured, and it will do the sub-assembly of missile systems were done. Then we can do the major assembly. And after major assembly is done, the whole integration part of the missile systems are done. After integration, it will be given for the testing, and it will be for the final application of the missile system is done. Overseeing the tooling development and manufacturing of physical prototypes are used for a testing. And after the final testing and a QA inspection will be carried out by all the mechanical engineering as engineer and mechanical systems will be done. And this is a final slide. As I said, I will be giving from the host of an institution of engineers mechanical division board. I would like to give the sufficient time for the question answer sessions, and we'll take in the questions from almost a lot of the participants are there. And also we'll give a time for an academician, vice chancellor. The next session is there. And the conclusion with a digitized digitalized performance engineering approach and use of advanced technologies. Use multidisciplinary data to create an accurate digital twin and predict mission performance and missile system at any stage in its development. Leverage a single 3D CAD and a CA environment to generate high-resolution models, then swiftly investigate missile stability at different operational points. In simple words, no technology available without mechanical engineers' involvement. No tech without mechanical. And I would like to conclude this and look for to answer the questions in the question answer sessions, especially on the manufacturing systems, because the time, with shortage of the time, we cannot go through the whole manufacturing process involved in all the missile technologies and missile assemblies. Thank you very much, and look forward the question answer session. Over to Brigadier sir. Thank you very much.
Thank you so much, Dr. N.T. Ranga Reddy. I'm so very grateful for your presentation. The next panelist we have is Dr. Biplab Paul, the Vice Chancellor of Sardar Patel University, Balaghat, that is in Madhya Pradesh. Dr. Biplab Paul is a renowned academician, researcher, and has vast experience in various educational institutes. He has a bachelor's degree from mechanical engineering from Government Engineering College, Jabalpur, and master's in the field of energy technology from Indore, Madhya Pradesh. He is diploma in management from NMIMS, Mumbai. He started his career from Kirloskar Brothers Limited and was in charge Industrial Engineering Department. He is presently, as I said, Vice Chancellor, Sardar Patel University, Balaghat. Dr. Paul was principal investigator of the research project funded by DST New Delhi and had also played a lead role in other research projects. He has presented his research findings in many national and international conferences and has published various research papers in international journals of repute, mostly SCI and Scopus indexed journals. His contribution in national and international technical consultancy is well regarded. He had been granted 2 Indian patents. May I now request Dr. Biplab Paul to give his presentation, please. Dr. Paul.
Thank you, Brigadier sir. The distinguished guest of today's webinar, the chairman of IEI Jabalpur Local Center, Propulsion Dubey, Ranga Reddy sir from Mechanical Engineering Division, then Srivanavasa, the brigade scientist, Sanjay Mehta, Honorary Secretary, and other participants. Thank you for giving me this opportunity. However, I feel I'm not a man neither from missile technology nor from rocket technology or rocket sciences. I'm a man of energy, specifically renewable energy. So, Brigadier Saab, you have given me a very difficult task to address this August gathering where people from missile technology, scientists, manufacturers are there. But I take this challenge and I will give a brief of the role of mechanical engineers. Role of mechanical, we call this mechanical engineers as aloo. Kisi bhi sabji mein mila ke kha jao. That is what the mechanical engineers is all about. So you can see me as a Vice Chancellor of Sardar Patel University. I am running all the courses, including all medical courses. So I am a mechanical engineer, but taking care of healthcare and everything. Not missile technology for now. But if I go back to the things that what is the role of mechanical engineer in missile system? Role of mechanical engineer is always in every system. That is what the crux of the matter is. And what is a missile? The missile is a thing, it's an object which is thrown to a target by giving some power so that the object can hit that particular target. And this is what the missile is. A missile, and whenever we go through this particular term as a missile, so we call it a structure, a missile, which is propelled by some power And when power is there, there will be an engine. And when engine is there, definitely it will go to the target. And then the guided, how to guide that particular object to that particular target. So control system plays an important role. So 2-3 things attracts me as a role of engineer in a modern missile system. One is missile, the structure itself. Without mechanical engineers, it will not be impossible for us to manufacture a missile system or missile itself, a structure itself. Mostly these are made of aluminum or some steel alloys. The previous thing is of the die casting in 2 halves. The molten metal is poured in the die and then joined in the welded form. Now the new technology has come up, as Dr. Srinivas Rao and Dr. Ranga Reddy has already dealt about us using the 3D technology, a 3D printing technology. These systems has been developed very high with a high precision. Why high precision is required? Precision is required because the friction plays an important role in this missile system. And the missile system works on various temperature and pressure zone. If we go 50 kilometers above the Earth's surface, the temperature is around near about minus 80 degree or so. It's a talk of pressure, temperature, humidity, friction. The role of mechanical engineers comes up in a wider perspective, because these are the parameters which is controlled by these mechanical engineers, so that the missile must not be damaged with all this changing atmospheric pressure and temperature, and it must go to the right direction. Now, if you go for the propulsion system, how it propels. So if any object has to be propelled, it has to be given power. The power given by either rocket or by jet engines. And when engines are there, definitely role of engineers, mechanical engineers comes into in a bigger way, because designing of engine, what type of fuel will be required, is basically a job of mechanical engineer. Although in the missile system, many of the engineers work together to make it happen. It may for the control systems, it's electronic people, for and a computer system is required for guiding such type of missiles and rockets to a target. Many type of fuel can be used. I was amazed during this, because Brigadier Saab has given me a difficult task. What type of fuel is used? So I have talked with many of my friends, those who are working in this particular field. They say it's a kerosene, and they call it as a refined petroleum RP1. So I was very amazed. The fuel which burns a lamp in a house basically is propelling that particular rocket, fueling that particular engine so that it can be propelled. Although, and one more thing, oxidizer, which is liquid oxygen. So when these things are come together, a jet engine gives produces a large amount of thrust, which requires a smooth ride on the from the target using this. The ICBM, many of the panelists have talked about surface-to-surface missiles and all sorts of missiles which is used, or intercontinental ballistic missile, which may attain 4,500 kilometers per hour. So speed is one more thing which has to be dealt with. Whenever speed will be there, definitely the power and the propellant, in case of many of the intercontinental ballistic missile, the liquid fuel also used, the solid fuel also used. And as far as the friction is concerned, So insulation, greater insulation is required while manufacturing this missile system, because it may go up to a range of 50 kilometers or more height. It may be more also in some of the cases. But if we consider 50 kilometers also, the pressure drops drastically, the temperature drops drastically, and due to this particular thing, lot of conduction, convection, and radiation takes place. So we have to take care of insulation also for the missile system, and this the guidance of this particular missile system can be done by various waves, that is either in form of laser, infrared, radioactive, specifically in case of targeted thing which is moving target, infrared is used. And when infrared, ultraviolet, these are radio waves, this type of things comes into picture, definitely role of mechanical engineers plays a very important role. As a man of energy, we know that in solar spectrum, infrared and ultraviolet, these are the invisible radiations are the more prominent one. Visible radiation and infrared plays a very prominent role in developing a system which is renewable energy. If you are developing a object which is which you need, when heat is required, you use infrared. When photovoltaics are used, we use the other visible radiation. But in a missile system, if it is a helicopter or a aeroplane or a missile itself is a target, definitely it generates huge amount of heat, and that heat can be traced out, and that heat is used. Infrared radiation can be tracked and to eliminate the target. The radio waves are also one of the thing. If we go for how guided they are, in most of the cases now they use the satellite system or internal navigation system or terrain control matching system. These are old technology already, terrain controlling, or but now the satellite based system are more prominent during this the guidance of this missile and targeting the target. I don't think I must speak much about the missile technology. I must talk about the role of mechanical engineers. With those mechanical engineers are ready with all the thermodynamics, all the heat and mass transfers, all the IC engine type of thing, and these and the manufacturing of the which includes casting or fabricating or welding, and these system the combination makes a mechanical engineer a perfect man to design this particular missile system. I thank you. I must not talk much in front of all these scientists, those who are specialized in missile system also. And thank you so much for bringing me into this panel. Thank you, Brigadier Saab. Thank you, Prakash Chandji Dubey. Thank you, Sanjay Ji, for giving me this opportunity to be a panelist in the topic called the role of mechanical engineers in a missile system. Thank you so much, sir.
Thank you very much, Dr. Biplab Paul. I'm extremely grateful for sparing your valuable time and give this wonderful presentation. Well, gentlemen, before we ask for question answer session, I would like to sum up because the audience is still listening to us, and there are almost about 50 participants who have joined us, but cannot be seen on the screen, but they are listening to us, and we will be opening their, we'll be rather unmuting them to ask question and answers. We have enough time, almost about 40 minutes for them to answer questions. There are very many questions which are coming up to me. They want to ask very many questions, but before I unmute the participants, I would like to sum up the three presentations. First one was by Dr. Srinivas Rao. He talked about the desired attributes of a mechanical engineer, which is extremely important. and he referred to something about that they should know about the system. As a maintenance engineer, I can totally commit and agree with Dr. Srinivas Rao that the days have gone when a mechanical engineer could say that I know about only the mechanical aspect of the system, but with the kind of electronics, optoelectronics, and the sensor systems coming in each and every equipment in the technological field, we as mechanical engineers need to be a system engineer rather than be specifically a mechanical engineer. So very kind of you, Dr. Srinivas Rao, you were absolutely bang on that issue. We also understood the knowledge of many skills required by the mechanical engineers. He also gave insight into new technology for precision strike missiles. What are the global and guided missiles? Their aerodynamics, propulsion system, guidance control, navigation, etc. He also touched upon the various launchers, different launch system, whether it was a ship launch, rail launch, road launch, or an air launch. During the end of his presentation, he was talking about the network-centric warfare, which is an important aspect in today's warfare. And we need to be knowing what all goes into a command and control information system. Thank you very much, Dr. Srinivas Rao. The second, of course, we had a very brief input from Dr. N.T. Ranga Reddy. And there are very many questions coming up for you because there are a lot of young mechanical engineers, the students who want to know from you that what are the scope for a mechanical engineer to start his own enterprise for a manufacturing of components of the missile system. So we will request you to touch upon this when the question answer session comes in, sir. And we are grateful to you for talking about types of systems, whether it was surface to surface, air to surface, surface to air, or an anti-satellite weapon system. The role of mechanical engineers is important in the missile systems. We are grateful for you, for your presentation to you, sir. Dr. Biplab Roy, Dr. Biplab Paul spoke about the role of mechanical engineer, the aspects of friction, humidity, pressure, temperature coming into a missile system. He talked about fuel and an oxidizer, that is liquid oxygen, various control systems. He also emphasized on the importance of subjects like thermodynamics, heat transfer, IC engines, workshop technology, etc., which are very much an important aspect and part of a mechanical engineering. Thank you. I once again thank all the three panelists for giving their thoughts and presentations. And now may I request Kingshuk Sen to unmute all the participants. There are 50 participants as of now. May I request you to please unmute them and then ask questions. Please.
Sir, participants can't be unmuted from here. Actually, the role of participants, as per the role of participants, they have to put the questions in the question answer box.
Okay.
And the moderator, sir, kindly go through that Q&A, that button.
Okay.
Questions are right there.
Okay, I thought they will be unmuted and they can ask questions directly. So I'll go one by one.
Sir, 3 questions are there, sir, kindly.
Yeah, I can see that, but there are very many. Dr. Suresh Vishwakarma, if you can listen to me, please do type your question on so that I can ask the relevant. So before I start reading out the questions, may I request Dr. N.T. Ranga Reddy to kindly tell us the scope of a mechanical engineer, where he can start enterprise in the component manufacturing for missile system. Please.
Yes, sir. Brigadier sir, thank you for your for a nice question which you are coming from the participants. I think there is a lot of scope, as our outstanding scientist explained. There is a Atmanirbhar Bharat scheme is going on and very serious manner. It was a Make in India series. Now government has made a positive, we can say negative list, but it is called a positive component. They say you are not supposed to import around 311. They made a phase 1 and phase 2, phase 3. There are 311 components and subsystem systems, which you cannot import anymore from any other countries to our defense applications. So there is a lot of opportunities for, especially for manufacturing engineers, and you can definitely select as academician sir was explaining. You can see the lot of opportunities available in the websites of in the DRDO or in the defense websites, and you have a, if you got a passion and if you got a patience, and definitely you can lot of opportunities in the mechanical engineer parts to go for a component manufacturing or sub-assemblies or the whole system to for our defense applications. And the defense is having a vision not only for an Indian our defense forces, but we are looking for a very high-end targets by our present government. Even we want to export a lot of defense equipments which was sufficiently developed and certified by our own forces, but there is an opportunity that we can export some systems and some components to out of this country in export method. And we can definitely say that this is the correct time for a mechanical engineers to be a part of entrepreneurs, especially in the manufacturing sector. I leave to, I think Dr. Srinivas Rao would like to answer, sir. Please go ahead, sir.
Just I want to supplement what Dr. Rangareddy has said there. See, I have been part of this missile development for the last 20 years. And I have been to every manufacturing company that has been doing some component or the other. I have seen from the days where we used to make a drawings and we used to make a prototype in a workshop, then go and tell him and he used to do it. That was a build to print. I saw the question. Somebody was saying component manufacturing. That was the days when we were early days where we were looking for component manufacturing. Even today we need component manufacturers. I'm not saying that, but then today we are looking more of a system builder than a component manufacturer. The component manufacturer then becomes the supply chain to the system builder. So we are now concentrating more on a system builder, that is build to spec product developer. That's where we are talking about as the new technology. If I'm making a control system, I'll give my end specification controls. That is, what is the forces it has to take, what is the dynamics, what is the form factor it has to take, what is the frequency of its operation, and what is the power that it on which it can operate, what is the arm length it can have, the boundary I'll give. But then he will design the complete control system, come back and give me the system. This is where we are looking from the younger generation which are going to set up their industries, so that they will have a wide bandwidth. But pure component manufacturing today, if you go to whether for the aerospace park at Bangalore or in Hyderabad, we have got huge number of companies, industries, and today sometimes it's a aerospace is a cyclic. If Boeing or Airbus orders get some huge orders, suddenly you've got huge order book position and all firms are full. If there is a order dip, then everything is a cyclic. So these are the areas in which we have to very carefully look at it. But if what we are looking as a country to be a people who can build the system. This is what I was, because I have done more than thousands of components. I got it realized throughout my career. From that experience, I'm telling you.
Thank you so much, sir. There is one Nirjar Basu. He's asking, sir, is there any plan of using nuclear technology for propulsion in India?
I am not seeing for the missiles. And see, this is all controlled regimes. We cannot say. I think, Brigadier, you are better equipped to answer rather than me.
No, I fully agree. This is not in the public domain as of now. And this question, though it was put, so I was very reluctant to put it across to you. I fully appreciate that this is won't be the right forum to discuss about the nuclear technology as of now, sir. Then there is one more question coming from Mr. Devashish Day. His question is, with the multitude of systems requiring vetting and firming in shaping a missile system, it is seen that limited perfection is achieved in the first rollout. Along with it comes surprising last moment provisional sanctions, with limited time being the interactable TOR. What should be the USP of development of such system? I
think this question would have been relevant if it had been put 10 years back. Today we are not in that situation. Give me a spec, I can 6 months or 8 months, I can give a perfect missile system today. because we have got a wide range of propulsion systems available. We have got wide range of controls. Today, even I need not do. Industry, if you give an order, we can just give them that overall design industry will make. That is the status which we have grown in the missile field. So this question would have been relevant 10 years back, not today.
So thank you so much, Dr. Rao. But I think, Devashish, you should be not only satisfied with the kind of answer you have got, you should be proud of being an Indian, that this is what the state we are in as a country. And the beginning of the whole program, Dr. N.T. Ranga Reddy did mention that the coming decades, rather this complete century will belong to India. And I think this answer goes a long way to prove that statement of Dr. Ranga Reddy. There is one more, sir. What is the demand of mechanical engineering in the next 10 years?
One more question which I am seeing, what is the level of a self-sufficiency? Can we intercept a missile without the help of foreign technology partners like GPS GLONASS?
You can you also saw that question, sir?
I saw that question. This is the question.
Please,
I just want to answer. We have got our own IRNSS, so we need not have to depend on GPS and GLONASS. Just want to clarify it. Indian regional navigation systems and all our systems are now built to interface with them.
I think this question can be taken up by Dr. Biplab Paul, sir. What is the demand of mechanical engineers in next 10 years? Dr. Biplab?
He was on mute. Vice Chancellor, sir, we are on mute, sir.
Dr.
Can
Biplab,
can you repeat the question, sir?
Yes, sir. Yes, sir. I'll do that. There's one anonymous attendee. I don't know his name. He says, what is the demand of mechanical engineer in next 10 years? Is a basic question, which is, I agree that, as you said in the beginning of your presentation, that mechanical engineer has never been in demand, but at the same time, never out of demand. So you would like to answer that question. What is the demand of mechanical engineers in the next 10 years?
Next 10 years, not for the next century also, mechanical engineering demand will be growing as all the sectors, which includes the automobile sector or the space rocketry sector or the service sector. In all the sectors, mechanical engineers are required. Now, what happens in case of mechanical engineering, we used to read the basic fundamentals. Now that has changed. We have integrated, the mechanical engineers have integrated themselves with the computer science, with the electronics, with the invent of mechatronics and all sorts of things. So we will find whenever there will be a development of a software, it will be developed for certain sector or certain industry. And that industry will be requiring mechanical engineers. So domain knowledge is always be there for there. So one has to have a domain knowledge first, and then technological upgradation with integration with the computer science. So as any other field grows, the mechanical engineer's role will be growing more and more. Thing is that you have to change your attitude, your working skills or your skill sets with time. You have to integrate yourself with computer science. You have to integrate with the electronics. You have to integrate with the environment so that your relevance will be there. And I'm sure that another 10 years or century, the role of mechanical engineers cannot be ignored in any of the sense, because it requires any of the component requires manufacturing, any of the component requires engines or refrigeration, air conditioning. So role definitely will be growing more faster, but it will be faster if you go through the integration with the other disciplines as computer science and electronics.
Right. Thank you, Dr. Biplab.
Brigadier Sir, can I add one small?
Yes, please, sir, please.
Yeah, as in a rather industry running for the last 30 years. So
yes, please.
I would like to say for all mechanical engineers, as long as you have a passion and you want to make your hands dirty, all mechanical engineers have a wonderful life, and definitely you have a wonderful opportunities to do. And don't carry away with the white collar jobs, what your IT field talks now. It is only temporary service industries, but manufacturing, always a brick and mortar industries will have a life. and you should be more passionate, and we have to feel proud. A blue collar jobs, what we call as a mechanical engineers, is always a country, nation, brick and mortar builders. And definitely, as our Vice Chancellor said, and our outstanding scientists sir was telling, lot of opportunities for the best and capable mechanical engineers. You have to be meet as the industry wants it, and academicians now, I think, come to the level, just you are not sitting in a lab, mobile and a screen, you cannot become a mechanical engineer. You have to come to the field, make your hands dirt, and be on the practical and be on the field. Then definitely a lot of opportunity.
We missed you, sir. Are you still there?
Yes, sir.
All right. Dr. Srinivas Rao. Dr. Srinivas Rao.
I think Dr. Srinivas Rao sir missed, I think, sir, his line.
Sir, there are a number of questions now coming in and the time still is permitting us. Can I read out a question for you, Dr. Srinivas Rao?
I think his connection might have gone. He has rejoined, sir. But he can read the question. Somebody can answer.
Yeah, I'll read it because it's in front of me. I think this has been answered, Mr. Ram Naresh Barman. He has again asked the same question. How many fields are opportunity for mechanical engineers? How can we achieve? Sir, please guide and motivate us. I think Dr. Biplab Paul and Dr. N.T. Ranga Reddy has given enough input on this question. So I don't think we can really take on this question. In the meantime, there's one question from a participant named Renji. He says, as a mechanical engineers are steering all these developments, what are the various metallurgy technology under development which helps the development of missile technology? It should be mechatronics engineer rather than restricting ourselves as mechanical engineer. Comment, please. So before I ask either Dr. Reddy or Dr. Biplab Paul to answer, I would like to just say, Renji, I mentioned this, that you cannot be any more a mechanical engineer. There is something known as mechatronics, optronics, sensor technology, because everything is getting into the the systems which are coming up, multi-discipline systems which are coming in now. So would you like to answer, Dr. Biplab Paul or Dr. N.T. Ranga Reddy? Can repeat this question. As a mechanical engineer are steering all these developments, what are the various metallurgy technology under development which helps the development of missile technology? It should be mechatronics engineer rather than restricting ourselves as a mechanical engineer. Comment.
Dr. Srinivas Rao is the best person to answer. Sir, please
right,
go ahead.
Right, sir.
First is, I don't want to say that mechanical engineer alone steers. A missile technology cannot be built by only one mechanical engineer.
True.
It starts from the physicist also. It starts on basic dynamics, which we have to do, functional dynamics, that's the physics which I have to apply, the laws of physics, the chemical engineer works, the electronic teams works. So it's an integrated. That's where I said again, it's a systems and systems approach. Now, any engineering, you study at a mechanical engineering as an undergraduate course, doesn't that you only have to round ourselves with that small segment. There is one area in which you have to be strong. And then as you build up, you have to add layers onto it, which makes it an integrated approach. So that's how you're called an engineer. You're not called a mechanical engineer or electronics engineer once you're outside. So let us leave that up to the graduation level. And as you build in the system, the core specialization in the area. If you're making an automobile, can a car today work with only mechanical engineering system? Today it's completely electrical car with an automated system. Just look at that way. So, and it has got everybody working on that. So you have to work in a team. You have to understand other members' team requirements, and you yourself has to contribute. So you need to understand what is the digital electronics portion of it. You need to understand the communication portion of it. You need to understand the metallurgy. And it's not only metallurgy. With composite materials coming in, there are many other things you have to learn about it. Basic chemistry. And all realizes, we keep on asking among yourselves, what is the physics of the system? Once you start asking physics of the system, then you will come out what is required and what is eventually needed. So Let us go beyond what we have learned just at the graduate level. That's what I wanted to say.
I'll add one point. Brigadier
Yes,
sir,
sir.
I'll add one
Yes,
point
Dr.
to
Reddy, please go ahead.
Dr. Vice, our Srinivas Rao sir's addition. I think engineers has to come out of one. Normally, we feel after 12th standard, you become 4 years study. You feel you become a full-fledged engineer, and it is enough. It is not so. I think you take other professions like a medical. You say 12 plus 5 plus 2 post graduation super specialist. So somewhere engineers has to find a way that only 12 plus 4 is not enough to be an engineer or to be a specialist where you call. As or maybe I am very sure Vice Chancellor sir will accept that we should go to the further your post graduation super specialist or in other subjects where you should do your super specialization to call really yourself an engineer to contribute whichever high-end systems are you want to involve or you want to make it. Thank you, sir.
Thank you,
Experience.
Dr. Reddy. Dr. Srinivas Rao, there are two questions coming from Canada. There's one Dr. Suresh Vishwakarma from Canada. He has specifically asked you two questions. First is, nowadays there are super specialized streams like including aeronautical engineering, aerospace engineering, aerospace material, and aerodynamics. How do you see the standing of today's hardcore mechanical engineer among engineers from these specialist branches while seeking career in defense sector?
I think my earlier answer still stands here. See, you have a basic
Hello.
engineering background on one core subject. Then you become super specialized in a particular zone if you are a specialist. If you are a journalist, you work integrated with systems. So just having for example, let me just take an aerodynamics. He has mentioned aerodynamics as a super specialist. Aerodynamics super specialization, he may go for transonic flow, supersonic flow. He may create different flow dynamics. He may go with a low density, high density atmospheric conditions. In all those different conditions, different speeds, he may work out all the equations. But then, how does he convert it into a profile? You need again a mechanical engineer to convert and create the profile which can withstand those aero loads. So this is where you need you cannot just say that BTech have done mechanical engineering. I do not want to know aerodynamics. Aerodynamics guy does it, but I need to understand what the aerodynamics profile he gives me, what are the force constants he gives me, and how that force constant varies, and what is the hinge point he varies. Then comes to me control dynamics. Sorry, I'm getting slightly more technical, which is not for this audience. But my point of here is a core mechanical engineer has to adapt according to the situation, and he may become a structural designer, or he may become a control designer, or he may himself become a aerodynamic designer also as he super specializes in it. So it again doesn't end with BTech 4-year course. It's a design on these areas is a continuous exercise if you want to work. And people have to work about 10 to 12 years beyond their core engineering if they have to achieve some kind of a hands-on specialization where we talk on the international forums.
Thank you so much, Dr. Srinivas Rao. There's another one from Dr. Suresh Vishwakarma from Canada, but I will rather move on to the other questions. There's one Arjun Reddy. Now, because he's a uniformed man, so I'll take on his question. He says, I'm Major Arjun Reddy, tank technology expert posted at Sri Ganganagar, Rajasthan. Firstly, congratulations to all the panelists, Dr. Srinivas Rao, Dr. Ranga Reddy, and Dr. Biplab Pulav, who have given an insight about role of mechanical engineering mission. Really enriching. All right, there's no question. He's just appreciating. Fine enough. There's one Dr. Mohammad Abid Ali. He's asking that CSE rated branches is future of mechanical engineering. He says, very nice and valuable presentation, sirs. Present most of the students to join CSE. I think this is computer science engineering, is it? And CSE related branches. What is the future of mechanical engineering? As I think has been replied aptly and abundantly by Dr. Biplab Pulav, that mechanical engineers will remain relevant for the coming years, not only years and decades, but for much more time here to come. Neeraj, for component developer, is this question again? He says, instead of a component developer, if we introduce system developer concept through outsourcing, how we will ensure a secured information integrity? I repeat, instead of component developer, if we introduce system developer concept through outsourcing, how will we ensure secured information integrity? Dr. Rao and Dr. Reddy, please.
Oh, there are enough mechanisms which we work. There is a non-disclosure agreement in place. And when we talk about, say, just giving one specification, need to spec of one particular system, you cannot create a complete system. There are enough checks and balances available when you make an overall system. So not to worry about that. There is enough measures are taken on the integrity of this. Not a problem. We have been doing it, not an issue.
Sir, I'll add one to the Dr. Srinivas Rao, sir, because he is the giver of the work for people like us. So we are the industry part of it. So we do a lot of defense, supposed to be very secret information or whatever you call it. We are just, as I said, we sign an NDAs, and we also do an exports, and we also do a different projects, and no industry will take any chance of leaking out information to outside, and even no other customer knows that who other customer project you are doing into. That way industry has matured enough in India, and there is no question of proliferation of information or any message or any drawings will go out of to anybody. So everything is secured, and all industries are matured enough to manage the data security.
Thank you so much, Dr. Reddy. I'll just take last three questions. Now that Arjun Reddy, Major Arjun Reddy from Ganganagar has put in a question now. He says, nowadays the seats for mechanical engineering in most of the engineering colleges are being opted in less numbers by youngsters. Why is it so? Dear Arjun, I think this has been answered by Dr. Reddy in detail. He said that if you are ready to dirty your hands, the scope for mechanical engineers is enormous. This white collar job of service industry is only short-lived. There's a long way for the mechanical engineers, and behold, the mechanical engineers will come into enormous demand, and seats will be not only full, there'll be long queue to get into the mechanical engineering discipline. Am I right, Dr. Reddy, or you like to add something more?
Yes, sir. I think Vice Chancellor can answer if anything.
I definitely want to answer this question. Actually, the engineering in previous cases, when I did my engineering, we have 800 plus seats in Chhattisgarh and Madhya Pradesh. Now we have 130,000 seats if you consider Madhya Pradesh and Chhattisgarh together. So what happened? The market forces derive which type of course will be required. At the advent of the service sector, specifically software industry, our export has crossed huge limits. So the demand in case of computer science engineering is more. In case of mechanical engineers, one or two mechanical engineers can sit and design and then manufacture. So they work like an engineer, designing the things, developing the things, and then handing over to a subordinate level, those who manufacture that, depend on drawing. The engineer's role is over. Only monitoring thing is there after developing and designing the things. However, in case of computer science engineering, you see maximum workforce comes and do the job they have to do. So there is nothing called subordination. Various system will be designed by various teams, and then when they be integrated. That's why the computer science demand is more and mechanical engineers is less. But once these engineers will start more higher than any of this engineering, because if you see on the ground, a mechanical engineer can work as a computer engineer, but reverse cannot happen. In core engineering sector, you will find an electrical engineer is a computer engineer, mechanical engineer is a computer, is a civil engineer, but reverse is not happening. So I definitely agree with Ranga Reddy sir. You have to dirty your hand, you have to use your brain, you have to be adaptable to many of the technologies, as Srinivas Rao sir said, and then only all this engineering will go side by side.
Thank you, Dr. Paul. Excellent. I'm so very grateful to clarify this issue. There's another last two questions, or maybe three. I still have time. This Dr. Suresh Vishwakarma is very active from Canada, and primarily because he belongs to Jabalpur Local Center and has moved to Canada. So, Dr. Paul, there's another question from him is that what sustainable practices in the defense manufacturing sectors you would academia to focus upon while preparing next generation engineers? I repeat, Dr. Paul, the question is what sustainable practices in the defense manufacturing sectors you would like academia to focus upon while preparing next generation engineers?
Sustainable technologies are always in demand, because now and then, every now and then, the technology changes, the use changes because of the so many environmental issues. Even if we go to the energy sector, previously the 80 to 90% electricity generated is through coal. Now we have adopted a technology of solar energy and biomass gasification and biodiesel, or all sorts of fermentation process is there. So we are now in the bracket of 60% using coal. So sustainability in the defense manufacturing system has to be adopted. We have to go for some technologies which will not be using these fossil fuels, which is non-environmentally friendly. And also we have to see how these particular technologies doesn't harm the environment and the human as a society. We are always concerned about the space, garbage, and all sorts of things. So while developing this technology, with the sustainability has to be there, so that the future generation can also benefit from the technological upgradation. It must not be, it has to be a reward for the future generation.
Thank you so much, Dr. Paul. There's one young student who says, I'm in a second year mechanical engineering branch student, a young boy by name Jani Basha Sheikh. He says, my question is how to fill the gap between the academic knowledge and industrial requirements.
Is it a question to me?
Anybody, sir, can answer, sir. Dr. Paul, or in case Dr. Reddy wants to do that. I repeat, he says, my question is how to fill the gap between the academic knowledge and industrial requirements.
Now I think our Vice Chancellor, sir, as was telling, and you come out of your classroom, and as you said, you come and work 1 or 2 months in every year of engineering. It got up to 4. Previously, when before my batch, there was a 5 years course, and you should have 1 year internship. Surprisingly, the short of internships have gone, and your practical exposures have come down. Now I request all the academicians to see that. I think a new education policy also is almost to say that you should work 1 month in every year of your course. Then you will himself understand what he is studying and what his industry is looking. The gap will be built up. So practical experience, come out of the campus, work with industry is the solution to build a gap between the industry and academy. I think Dr. Bipin Paul sir should add for it if anything is left out for the students.
Actually, what happens now, the system of whole education system, we have to change, because theory will not do. Integrated with that, you have to have higher order of learning. Now, what higher order of learning is implementation of all those things which you have learned. So what we are doing in academician, Sardar Patel University also, we are tying up with industries. So we have a theoretical class as well as practical class. We are tying up with Siemens, we are tying up with Tata Motors also, so that this hand-on experience will be then. We are tied up already with Red Hat and many of the companies in Mumbai in software as well as mechanical engineering stream. Already we have started training of this AutoCAD and Pro-E and Nastran and ANSYS and these type of softwares. These are the basic tools with your theoretical knowledge, which will, because if you add those skills to you, your employability ratio will be more. You will be able to place more students, and when the skills will be developed, then only these mechanical engineers will have a definite relevant role in the society.
Thank you.
Thank you so much, Dr. Paul. And I'm sure the skill includes both hard and soft skills, which are there very important. Last question, sir, for the panelists. Which are the leading organizations, public or private, working on the latest missile technology in India?
To the Dr. Srinivas.
This would be the last question.
I think the first is that whoever has written the anonymous, he has not mentioned.
Oh, private sector.
Okay, second thing is, this is not a question which we have to answer. It is available on the internet. They can even go to DRDO websites. DRDO website gives a list of industries working for us.
Very correct.
We all know BDL is the main missile producer, and there are many other companies. So they can look at it. It's difficult. It's not correct, but for us to answer here in a panel.
Right. I think that should suffice, ladies and gentlemen, all those participants who had joined. I now invite the Honorary Secretary of Jabalpur Local Centre, Engineer Sanjay Kumar Mehta, to please vote of thanks.
Mehta sab, unmute and you go ahead.
Engineer Sanjay Mehta, you are muted. Actually, you have to unmute yourself.
Kindly unmute, sir, from your side.
Now, Engineer Sanjay Mehta for his proposing of vote of thanks. No, you are still muted, young man. You kindly unmute yourself and you will be through to us. No, not yet. There were almost about 16 odd questions which were shot at us, shot at the panelists, and out of which I think we have been able to address almost 10 of them with the brilliant answers from all the three panelists, Dr. Srinivas Rao, Dr. N.T. Rangareddy, and Dr. Biplab Paul. And most of the students had that academic questions which Dr. Biplab Paul has handled very well. And I'm so very grateful. Dr. Engineer Prakash Chand Dubey, can I take on the responsibility of proposing the vote of thanks? Dr. P.C. Dubey? Dr. P.C. Dubey?
Yes. He is having some audio problem. So I am delivering the vote of thanks as per your permission. Okay, sir.
Can I?
Good afternoon, Good afternoon, everybody. Attends the webinar. Respected dignitaries, Dr. H.O. Thackeray, President, IEI, Dr. G. Ranganath, Chairman, KATE, IEI, Dr. N.T. Rangareddy, Chairman, MCDB, IEI, Dr. Vice Srinivas Rao, Director, NSTL, Dr. Biplab Paul, Vice Chancellor, Sardar Patel University, Balaghat, respected Brigadier Vipin Trivedi ji, the moderator. Today, Jabalpur Local Center organized a webinar on the role of the mechanical engineer in missile system. I am not going deep in the topic as our panelist has already described it in very deep. At the very beginning, on behalf of the Institute of Engineers India Jabalpur Local Center, I would like to thank our President IAI Dr. Thackeray for his consent for this webinar. I also like to thank Dr. G. Ranganath, Chairman Kate IAI, Dr. N.T. Rangareddy, Chairman MCDV IAI for approving this activity and spare their valuable time. I am thankful to our panelists of today's webinar, Dr. White, Srinivas Rao, Director NSTL, Dr. N.T. Rangareddy, CMD Legend Technologies India Private Limited, and Dr. Biplab Paul, Vice Chancellor, Sardar Patel University, for accepting our invitation, address the gathering and enlighten us with the role of the mechanical engineer in defense technology. I like to thank Brigadier Vipin Trivedi, who is moderator of this webinar, for his efforts to organize the webinar. He is the one who took initiative from the very beginning, from the selection of the topic, panelists, etc. He has taken all the pains for conducting the exam. I am sincerely grateful to him that he has brought such a knowledgeable speakers among us. I also salute his thinking that he chose this topic in today's context so that today's young generation can be benefited. Last but not the least, I am very much thankful to the executive committee members, participants, students, members, and others for attending such important webinar. I also thank all those who have contributed directly or indirectly in conducting this webinar, making it successful. Thank you. So thank you, sir.
Thank you, all the three panelists. Once again, sir, I'm so very grateful and honored that you had honored my request to come and address such a large participants, mostly who had come from various colleges. Professors were there on the panel, as the participants. Thank you once again. And Kingshuk, you can now close the proposal. Thank you so much, sir. Dr. Srinivas Rao, Dr. Rangareddy, and Dr. Biplab Paul. Thank
you, sir. Thank you so much.
Thank you, sir.